All right, so we're looking at linear functions here, and linear means that a couple of things. It means that the value of x in the function has a degree of 1, an exponent of 1. It also means that when we graph this, we're going to have a straight line. So, or a line, I should say. So, the function is going to look something like that, right? It's going to be a straight line somewhere on the graph. Okay, so let's see. Table here, we're going to complete the table, and we're not given any values to start with. So from what I'm seeing here, it looks like you can choose whatever values you want for x, and then when you substitute x here with those values, you'll get whatever the y value is for that particular x value. So since there's nothing indicating that you have to use certain numbers, I would say a couple of things. I would say one, probably it would be helpful to use a negative and a positive number. You don't have to, but that's probably a good practice. And I would pay attention to the denominator. If there's a fraction in the slope here, the number in front of x, that denominator can be helpful to you. I would just say it's a 2. So I'm going to use a multiple of 2 for my x value so that I don't end up with a fraction for my y value. It's just a way to kind of avoid that. Keeps the graph looking a lot cleaner. And so I can use, I could use -2 and +2, for instance. So all I'm going to do is take this equation, and where it says x, I'm going to put the value that I put in here for x. Okay, so -1. All right, so 3/2 times -2, or that you're just multiplying. So that's -6/2, which is -3, -1 is -4. So y is -4 when x is -2. So we can plot that point. So we go left 2 and down 4, put a little point there. It's not so little. Should be a round dot. That one's not very pretty. All right, now let's do the same thing, but let's plug in the +2. I put it over 1 just to help me think through it. So 3 times 2 is 6. 2 times 1 is 2. 6 divided by 2 is 3. So I've got 3, and I bring down the -1. That's my phone. 3 minus 1 is 2. All right. So when we put in a +2, we get out a +2. So 2, 2. All right. So we had -2, -4 for the first coordinate, and then we got 2, 2 for the second one. So 2, 2 is our second coordinate, and now we can connect those points to with a straight line, and that gives us our exact line here. Now we would want to do that as precisely as possible, extending it out. The other side is not, see if I can do it here decently. It's fair. Okay. It's not perfect, just 2 points, but that gives us an idea for sure of where the line would be. So we've plotted our 2 solution points. We drew a line as, I wouldn't say exactly, but as close to exact as we could here. And then it says find a different solution point on the line. So a couple of ideas with that. You might, it says find the solution point on the line. So to me, it looks like it's saying find a spot on this line itself. It's not saying pick a third x value and plug in to get y. So as I look, it looks like it crosses here on an exact nice coordinate. This appears to be one as well. So, that's something to think about. I would probably go, I feel the most confident about this one. And so that different solution point is at 0, -1. So that would be my third solution point. You could always plug it in as well. And that's an easy one to plug in because, we're plugging in 0. That's the x value of the coordinate. anything times 0 is 0. And so 0 minus 1 is -1, which is our y value. So that helps us to see that that's correct. All right, I hope that's helpful, and I'll see you next time.